Today we introduce Henri Poincaré, celebrated as the last Universalist. Join us as we explore the remarkable mind, deep mathematics, and interconnected genius of one of history's ultimate polymaths. Hailed as the Gauss of modern mathematics, Henri Poincaré's genius spanned pure mathematics, theoretical physics, engineering, and philosophy. From pioneering algebraic topology and chaos theory to serving as a mind inspector and philosophical luminary, Poincaré truly lived as a poet of the infinite. Poincaré's childhood diphtheria and extreme nearsightedness left him physically clumsy and unable to see the chalkboard. Yet these limitations forced brilliant adaptation. Relying on unmatched auditory and spatial memory, he constructed and manipulated intricate equations and geometric spaces entirely within his mind before committing them to paper. Hailed as a monster of mathematics at École Polytechnique, Poincaré studied engineering and investigated a fatal mining disaster in 1879. That same year, while serving as a mine inspector, he completed his doctorate in mathematics, pioneering groundbreaking methods for differential equations entirely as a recreational pursuit. Poincaré mastered mathematical creation through a strict 4-hour daily schedule, protecting his rest at night. Solving equations mentally using spatial memory, he deliberately set aside tough problems, letting his powerful subconscious engine work autonomously to deliver sudden, brilliant flashes of insight. Poincaré transformed mathematics by moving beyond rigid, step-by-step algebraic proofs. Championing visual geometry, top-down intuition, and first principles, he shifted the focus from finding exact numerical calculations to grasping the qualitative behavior and overall structure of entire systems. In 1985, Poincaré revolutionized the study of shapes by inventing algebraic topology. Introducing formal homology, beta numbers, and the fundamental group, he replaced fragmented intuition with rigorous mathematical tools to classify multidimensional spaces and evaluate continuous deformations. In 1904, Poincaré posed a century-long riddle. Is every simply connected three-dimensional space essentially a sphere? Where loops shrink to a point on a sphere, they snag on a torus. Defying mathematicians for 99 years, this monumental conjecture was finally proven by Gregory Perelman in 2003. In 1987, King Oscar II offered a prize to solve the n-body problem. Poincaré proved standard series expansions failed to calculate exact orbits. Instead, he mapped their stability using qualitative differential equations, fundamentally rewriting celestial mechanics and winning the prize. While analyzing celestial orbits, Poincaré discovered that minute changes in initial conditions yield wildly unpredictable outcomes. Decades before modern computing, he laid the foundation for chaos theory, proving that absolute long-term predictability in our solar system is impossible. Standing alongside Lorentz and Einstein, Poincaré co-discovered special relativity. Having postulated the constant speed of light in 1898, he established the principle of relativity, named the Lorentz transformations, and mathematically predicted four-dimensional spacetime weeks before Einstein's seminal 1905 paper. Poincaré and Einstein took distinct routes to relativity. Poincaré approached the universe through Maxwell's electromagnetism, electron dynamics, and group theory. Meanwhile, Einstein took a kinematic path, axiomatically building his theory from two fundamental postulates independent of electron structure. Beyond mathematics, Poincaré profoundly shaped philosophy through conventionalism. Celebrated by the Académie Française for his lucid prose, he argued that scientific theories are neither absolute truths nor raw facts, but convenient conventions, the most useful frameworks for organizing human experience. Far from bouncing between isolated fields, Poincaré's genius was unified by a single master key, the qualitative theory of differential equations. This groundbreaking approach provided the exact framework needed to map chaotic three-body orbits, pioneer algebraic topology, and build the mathematical scaffolding for special relativity. Henri Poincaré stands as history's last true universalist, excelling across all mathematics and physics of his era. Rather than merely building on existing foundations, he returned to first principles to invent brand new branches of science, a true poet of the infinite and bard of science.